in the Mekong Delta, and is alongside of the Delta River. And speaking of river, we can illustrate that about water. And as similar as our topics today, we'll be demonstrating wastewater solutions in the downtown or local. Well, in most local or urban, and not only in Cần Thơ, but when I travel here for this contest, I can also see that the Saigon River along the Open Gate Avenue is also polluted. So let's talk about the statistics for our urban, which is the statistic that we collected in Cần Thơ. So you can see that the collected water is around 40,000 meter cube per day, and in which the treated as around 1,750 meters cube per day. And in percentage, it will be 43 to 75%, and for the untreated water, it will be 56 to 25%, which is at 225. So with the statistics, we can see that the sources of pollutions are coming from the domestic waste, which is wastewater from households, from living activities, in like, for example, wastewater or hygiene. And another thing is the organic waste from the agriculture activities, like watering or like shrimp ponds, etc. Those are the main sources of the urban waste, of the urban waterways. So the project goals I would like to present to you today is included with four goals. Is reduce the bioplantation pollution, antibacterial, no toxic chemicals, and agricultural reuse. As you can see, our prototype consists of 5 stages of process, which first is the filtration process, which we will remove solids from liquids and then continue to coagulation, in which we will remove the total solids, which is TSS, and then the potted treated water will continue to the biochar, which we have 3 sections. For the rocks will also be removed for the extra TSS, and the sand will remove the heavy metal. And finally, the biochar will remove the phosphorus and the ammoniac, which is the main components in wastewater. And finally, the ozone and the UV filtering, we will be putting together for support. If we use the UV alone, the statistics, the efficiency will be only at 20%. And for the ozone, it will only be 30%. But if we put it together, which supports each other for bacteria disinfection, the efficiency would be 60%. For the technical parameters of our prototype, we can see that the ozone can collect 200 milligrams per hour and 1 milligram per liter, and the total voltage usage is around 50 watts. And for the cost the total cost is 2,000 VND per meter cube of water, which is cheaper as this prototype. And the filtration for water treatment is around 100 liters per hour. And this is IoT remote, so the system can be built in and resident control from a distance. Finally, the standard objective is for the standards to be the output water is to match the TCBN 14 and 2008. It's the Type B standards for urban water treatment. And for our prototype database and results, as you can see, the yellow line and the gray line is the two that illustrate the unprocessed water and the usage water. So water, clean water, almost clean. And for our prototype result, which is this is the orange line right here. As you can see, it is over the standard of Vietnam VCVN. It is surpassed the standards and is almost parallel to the standard and the clean water. So I think if we added more process and more stages, that we can make it closely to the usable water. And yeah, this is the end of our presentation. I would like to thank you for listening.